last lesson of the day, and again I'm going to give you 2 days to do this, which will allow you extra time to do your test review and your exam review. I will open the test up on Friday so that if you want to do it Friday and be done, you can. But this lesson, or the video, might be a little bit long, but the lesson itself is pretty simple. And the nice thing is, this is the only concept that we're adding to your test from the quiz that you took on Tuesday. So we're going to compare linear, exponential, and quadratics. So I didn't even put these pages in your notes because I just want you to follow along for a few minutes here. But if you do have a note packet printed, you can also follow along on page 18 of your notes. Okay, and it says, these examples say, can it be modeled by a linear function? Explain. So then you look at the table that they're going to give you, and you start trying to figure out the pattern. Okay, well this is a pretty basic pattern. You can just see, like it has noted here, that the first difference, and that's important because we're going to come back to that, is 2. We're going up by 2 every time. And then we're going up by 1 every time over here. So when you're going up by a constant amount, that's going to tell you right away that it's most likely linear, as long as you're going up by a constant amount over here. So they want us to write this equation. So we got y equals mx plus b. Remember, for the millionth time this year, m is your slope, which is your change in y over your change in x. B is my y-intercept. So in this case, my y-intercept is right there. My slope is this number over top of that number. So my slope is 2 over 1. My y-intercept is 3. So my function is y equals 2x plus 3. So they kind of led you on this one. Is it a linear function? Explain. Well, we did it. It goes up by a constant amount. It has the same slope throughout. And that's really what your explanation would be, is that it has the same slope and for all the values in the table. Okay, and then it says as x increases by 1, how does the y value change? Well, it increases by 2. So then we go here. It says, can the data in the table be modeled by an exponential function? So this is a little trickier. Now you start trying to figure out what's going on here. Okay, and same thing here. In this case, our a is same thing, that y-intercept. So now the a is the y-intercept. Okay, and the b is what you're multiplying by. So in this case, is actually, well, my a is 1. And my b, we're doubling every time. When we go up by 1 here, we multiply by 2. And that's what they're doing. The way they're checking this is the ratio of y values. So what they're taking is 2 divided by 1, 4 divided by 2, 8 divided by 4, 16 divided by 8. And notice they use the word consecutive here. The ratios of consecutive y values are the same. So what are we multiplying by? This ratio is 2. So my formula here is 1 equals 2 to the x. I actually went over in the Desmos and I put another one in real quick just to show you the difference here. So I put in 2 times 3 to the x. So again, over here, I'm going to move my mouse over here. This point right there, 0, 2. That's where I get my 2 from. That's my y-intercept. Where do I get my 3 from? Remember, any one of these, 6 divided by 2 is 3, because I did consecutive numbers. And even this 0.6 repeating divided by 0.2 repeating is 3. 2 divided by 0.6 is 3. Any of these consecutive numbers, when I divide one by the previous number, I'm going to continue to get 3. And that's a little bit trickier one. I thought that we needed a little trickier one than the example they gave us. And now we get into quadratics. Remember our quadratic, our basic quadratic, it's just this x squared function, and it makes that U-shaped right on your graph. And now we're going to deal with something called the second difference. So if we just look at this data over here, and we just look there, you're like, wait a minute. We're not going up by the same number because we go up by 6, and we go up by 10. Oh, not linear, so I erase and try again. Well, if it's not linear, wait a minute here. Look at this, I multiply by 3 times 3, but wait a minute. 9 times 3 is 27. Or if I'm going backwards like we did on the previous page, 9 divided by 3 is 3. 19 divided by 9 is roughly 2. So that doesn't work either. So I think you do the first two simple options, and then you come back. And now this one's a little tricky because now you have to go not just to the first difference, you have to go one more time to the second difference. So notice here, where'd they get the 6? They did 9 minus 3, 19 minus 9, 33 minus 19, and 51 minus 33. And that's where they're getting these numbers from right here. Then they do it again. Because look here, now, difference of 4, difference of 4, difference of 4. Now you have your equation. And this will tell you that it's a quadratic. And we get down here, and it says, does a linear, quadratic, or exponential function best model the data? Explain. So we can go through some examples. And there's 3 here. So a decent guess. So maybe you're going to have one of each. And I think that's a pretty good strategy when you guys get to a test or quiz. If you got 3 questions in a row and they're giving you 3 different choices, not always, but trying to see if maybe one works for each. It's a safe guess. And again, it's not always the case. So don't go and do that on your test because maybe there's 2 and 1. But let's just start here. If I go up here, I'm subtracting 3. And now I'm subtracting 9. And then here, I'm subtracting 15. And here, I'm subtracting 21. That's none of these. But now let's go to the second difference. Because now look what happens here. I subtract 6. I subtract 6 again. And I subtract 6 again. This first one is a quadratic. What is my reasoning? Well, it has a second difference of -6. second difference of negative 6. All right, well, hopefully we don't have to do that one again, because those ones are definitely the trickiest ones. Now look what happens here. I go up, and I immediately think it's either got to be plus 8 or times 3. But then when I come here, I'm no longer adding 8, I'm adding 24. So then I go to my second guess, and I start doing either going backwards, 36 divided by 12, 12 divided by 4. That will tell me that it's 3. So if you can't figure the number out, you can always divide it out and figure out. But I can look here, and you guys are smart enough. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 must be 108. So this one here is exponential. Because you're multiplying y by 3. Or you could go back and explain like they did up here. The ratios of consecutive y values are the same. Whatever works. And then this one here. Yeah, I'll start off with the easiest one. I always see if it works. So subtract 8, subtract 8, subtract 8. So this is a linear function because you are subtracting I don't know why I put it out there. There why. Subtracting the same number. It's got that common difference. So now the directions actually, this is supposed to be on this next page. Okay. And they want the same thing. But now they want you to write the one that fits the graph. So I really hope, guys, after being in this class, you can look at this and say linear line without even thinking about it. Right here, going up by a curve, exponential. Here, U-shape, quadratic. You should be able to do them just that quick. That's why I think this is a relatively easy section. It does get a little trickier now because then they want you to write the equation. Well, what am I going up by? Up 2 over 1. Up 2 over 1. So that's my slope is 2 over 1. What is my b? What is my y-intercept? 3. So your equation, because it asked for that, 2x plus 3. My exponential one, what are we going here? Every time we go from one number to the next. Remember, it's got to be consecutive. So negative 1 to 0 is consecutive. 4 divided by 2 is 2. Well, guess what? I could do these two because they're consecutive. 2 divided by 1, also 2. So that is my ratio that we're going by. So this one, y equals, remember a is that y-intercept in this case. Now that's a little tricky because up here, my y-intercept at the end, an exponential, it's at the beginning. My 3 here, sorry I had to make a little edit on the video. My 3 here is my intercept, that's at the end. Now my intercept's at the beginning. What is my intercept? It is a 4. What am I going up by? 2 each time to the x. The quadratic ones that you guys are going to get are going to be really basic. So I would just start with x squared and then look at this vertex point. It's 0, negative 5. So I would immediately try x squared minus 5, see if it works. And this is where I'd be hopping over to Desmos. And I'll be honest, if it isn't one like that, it's gonna be something very basic, like that. Or if we got wider, there. But any of these where it asks for it, it'll be really basic. Okay. So that one's just x squared minus 5. And you could check it with Desmos, like I said. So here they are again, a little summary if you need them. These graphs do not match what's down here. These are just the, what we call again, the parent functions. This is just simply y equals x. This is x squared, and that's is that 1 times 2 to the x, just your basic 1. So your homework is the same stuff. And I'm not going to make you do this down here. So if you watch this video, good job. You're going to be smart enough to know to skip this. 1 through 10 is your assignment. So you got 6 of them here where it just asks linear and explain. But down here they do want you to write the graph. And these are, this is a negative because it's upside down. And this one here, because it's getting smaller, then you're going to have a fractions in the spot of the b. So like, for example, 1/2, because you go from 4 to 2. Well, how do I do that? Well, consecutive 2 divided by 4. Remember, you go to the previous one. Or you do 1 to 2. Okay. Apologies for the long video, but this is the last one of the year. You're going to upload just these 2 note pages here, and then the 2 pages to the assignment. So you got 4 pages to upload. And that's it. Have a good day.